In this video, we're going to talk about how to add and subtract radical expressions. So remember, we talked about how to combine like terms. Like terms are terms with the same variables raised to the same exponents. So remember, we can use this to simplify algebraic expressions. All we do is go through the expression and identify the terms that are alike. And then we can put them together by combining their coefficients, and that allows us to simplify the expression. So we can extend this idea to radicals. Radicals that contain a root with the same radicand and the same index are like radicals. So notice here the cube root of 2x and 5 times the cube root of 2x are like radicals because these radicals have the same index and the same radicand. The square root of 4 and the square root of 5 are unlike radicals because although the index is the same, the radicands are different. So the fifth root of 6x and 3 times the fourth root of 6x are unlike because although the radicands are the same, notice that the index is different. So remember we talked about simplifying radicals, and this is very important when trying to identify like radicals. Because if you look at the square root of 12x and the square root of 3x, you may say, well, they're unlike radicals because they have the same index, but the radicand is different. Well, what if we simplify 12x? Remember, we can simplify 12x by separating into 12 and x, and then notice how 12 has the factors of 4 and 3. So then if we take the square root of 4, we get 2 times the square root of 3, and then we still have the square root of x over here. When we put everything back together, we get 2 times the square root of 3x. Well, notice that now 2 times the square root of 3x and the square root of 3x are like radicals. So when you're looking at these, you want to make sure that all your radicals are fully simplified before trying to determine whether they're like or unlike. So what we can do is use this idea to add and subtract radicals just like we did with polynomials in like terms. So you can add and subtract like radicals by combining their coefficients. Remember that if a radical does not have a coefficient written in front of it, that's an implied 1. And if you have unlike radicals, you can't combine them and you just leave them separated with a plus or minus sign between them. So for example, in this first problem, we're trying to do 4 times the square root of 3x plus 5 times the square root of 3x. So we can combine them because those are like radicals. So we're just going to combine 4 and 5, so that's going to give us 9 times the square root of 3x. In the second problem, notice that we do have like radicals because both of them have an index of 3 and the radicand in both is 4x. So we can do 6 minus 3, which gives us 3, and we have 3 times the cube root of 4x. So now if we look at this last example, notice that these are unlike radicals because the radicand is the same, but the index is different on both of these. So these unlike radicals, you're just going to leave them separated with that plus sign between them because we cannot combine them. So what we're going to do to add and subtract radicals is first make sure that all of our radicals are fully simplified. Then we'll add or subtract like radicals by combining like terms and leave unlike radicals separated by a plus or minus sign. So let's try simplifying this first expression. We have the square root of 98 minus 2 times the square root of 32. So first I'm going to look at each radical individually and make sure that everything is fully simplified. So let's look at the square root of 98. So the square root of 98 can be divided by 49, so we can rewrite this as the square root of 49 times the square root of 2. And the reason I did that is because 49 is a perfect square. The square root of 49 is 7, so this can be rewritten as 7 times the square root of 2. Now let's look at this next radical. So the square root of 32 can be rewritten as the square root of 16 times the square root of 2. The square root of 16 is 4, so we have negative 2 times 4 times the square root of 2. Negative 2 times 4 is going to be negative 8, so we have minus 8 times the square root of 2. Now we can put these two terms back together and notice that now you can see that they are like radicals. So we have 7 times the square root of 2 minus 8 times the square root of 2, which is negative 1 times the square root of 2. But remember, we usually don't write those coefficients of 1, so we can just write this as negative square root of 2. And that is the final answer. So now you can go ahead and pause the video and try doing this example on your own. So we can first start off by simplifying both of these radicals. The square root of 8 I can rewrite as the square root of 4 times the square root of 2, and that turns into 2 times the square root of 2. So when I multiply by that coefficient of 4, I get 8 times the square root of 2. Square root of 50 can be rewritten as the square root of 25 times the square root of 2. The square root of 25 is 5, and then when I multiply by the coefficient of 3, I get 15 times the square root of 2. So I have 8 times the square root of 2 plus 15 times the square root of 2, which equals 23 times the square root of 2. So now let's try this example. So although we have 3 radicals here, the idea is still the same. I'm still going to try to simplify and then see if I have any like radicals. So I have 5 times the square root of 90, 4 times the square root of 20, and minus 3 times the square root of 40. Okay, so 5 times the square root of 90. The square root of 90 I can rewrite as the square root of 9 times the square root of 10. So I have 5 times the square root of 9 is 3, and then I have the square root of 10. So 5 times 3 gives me 15 times the square root of 10. 4 times the square root of 20, well, the square root of 20 I can rewrite as the square root of 4 times the square root of 5. So I have 4 times the square root of 4, which is 2, and then the square root of 5. 4 times 2 is 8, so I have 8 times the square root of 5. So I now have negative 3 times the square root of 40. The square root of 40 I can rewrite as the square root of 4 times the square root of 10. So I have negative 3 times the square root of 4, which is 2, and then I have the square root of 10. Negative 3 times 2 is negative 6, and I have negative 6 times the square root of 10. So now let's go ahead and put all of these terms together. So I have 15 times the square root of 10 plus 8 times the square root of 5 minus 6 times the square root of 10. So all 3 of these are not like terms, but I can just combine the 2 that are. So I can pull out this 15 square root of 10 and minus 6 square root of 10. And then I'm just going to leave this 8 square root of 5 right here. So when I combine these together, 15 minus 6 will give me 9 times the square root of 10. And then I'm just going to leave that with the plus 8 square root of 5. Okay, so remember those unlike terms you just leave separated with a plus or minus sign. So now you can go ahead and pause the video and try doing this example on your own. So first, remember we simplify everything. So the square root of 12 becomes the square root of 4 times the square root of 3. So when I do this, I get 12 times the square root of 3. The square root of 32 I rewrote as the square root of 16 times the square root of 2. The square root of 16 is 4, and so 5 times 4 gave me 20, so I have 20 square root of 2. Negative square root of 72 I can rewrite as negative square root of 36 times square root of 2. And then square root of 36 is 6, so I have negative 6 square root of 2. So finally, I put together all of my terms, and so I have 12 square root of 3 plus 20 square root of 2 minus 6 square root of 2. So that 12 square root of 3 is just going to stay as is because it has no like terms, and then 20 minus 6 gives me 14 square root of 2. So now let's try this problem. So notice here we have 2 cube roots, but the idea is still the same. You're still going to work on simplifying because notice that at first glance, both of these look like unlike terms. So the cube root of 320, I can simplify that. That's going to be the cube root of 64 times the cube root of 5. The cube root of 64 is 4, so this is going to give me 4 times the cube root of 5. Now let's look at 2 times the cube root of 135. The cube root of 135 I can rewrite as the cube root of 27 times the cube root of 5. So I have 2 times the cube root of 27, which is 3, and then the cube root of 5. So 2 times 3 is 6, and I have 6 times the cube root of 5. So now I can go ahead and put these terms together. So I have 4 times the cube root of 5 plus 6 times the cube root of 5. So 4 plus 6 gives me 10, so I have 10 times the cube root of 5. So now you can go ahead and pause the video and try doing this example on your own. So we have 2 fourth roots in this problem, so remember to use your fourth roots chart to help you out. The fourth root of 243 can be rewritten as the fourth root of 81 times the fourth root of 3. The fourth root of 81 is 3, so we have 3 times 3, which is 9, times the fourth root of 3. Minus the fourth root of 48 turns into negative fourth root of 16 times the fourth root of 3. The fourth root of 16 is 2, so we have negative 2 times the fourth root of 3. So 9 times the fourth root of 3 minus 2 times the fourth root of 3. 9 minus 2 gives me 7, so I have 7 times the fourth root of 3. So remember, you can add or subtract radicals by combining like radicals. If you have unlike radicals in the expression that you're trying to simplify, leave them separated by a plus or minus sign.